Batteries used to be the quiet part of technology. Today, they're geopolitics. They decide which factories open, which cars win, and which countries control the next industrial wave. Storage is becoming the new oil. And the race to master it will shape prices, jobs, and power for decades. So, who wins the battery century? 1. Big picture. Energy storage has moved from niche to necessity. Solar and wind are now major sources of electricity, but they depend on weather. Storage turns variable into reliable. Electric vehicles scale by the millions each year. And batteries are their engines, their tanks, and their most expensive component. Grids need stability. Homes want independence. Factories want predictable power. And countries want energy security. All of that depends on storage. Governments in the United States, Europe, China, Japan, and India invest heavily in battery plants, mineral processing, recycling systems, and research. The global battery market already sits in the hundreds of billions. It touches cars, trucks, ships, phones, data centers, factories, and homes. To call this a battery century means something simple. Whoever masters storage will shape the next industrial map, the way oil shaped the last one. 2. The technology stack. Think of battery technology like a 4-layer stack. Layer 1. Chemistry. 2 chemistries lead today. LFP, lithium iron phosphate, cheaper, safer, long-lasting. Perfect for mass-market EVs and grid storage. It trades energy density for price and stability. NMC, nickel manganese cobalt, higher energy density, more range in cars. More expensive, uses scarcer materials. New chemistries are rising. Sodium ion, cheaper materials, good for scooters, small cars, grid storage. High manganese and silicon anodes, push density higher. Solid state. Promises faster charging and higher safety. But solid state still faces challenges in manufacturing, interfaces, and cost. Layer 2. Materials. Lithium, nickel, cobalt, manganese, graphite, copper, these are the backbone. Every shortage or price spike affects the entire industry. Layer 3. Manufacturing. Cells to modules to packs to systems. A few percentage points of scrap can make or break a factory. Dry rooms, formation lines, and quality control create the cost curve. Layer 4. Integration. In EVs, batteries shape the car's architecture. In homes, they become appliances paired with solar. On the grid, they act like power plants with software. Storage is not one device, it is an entire industrial stack. 3. The supply chain race. The battery supply chain has 3 big stages: mining to refining to cell assembly. Stage 1. Mining. Lithium from brine or hard rock, nickel from mines, graphite from natural or synthetic sources. Mining is slow to expand. Permits, water use, land rights, and community concerns slow every project. Stage 2. Refining. This is the choke point. Turning raw materials into battery-grade chemicals requires expensive, specialized plants. One region currently dominates this stage, thanks to decades of investment, skilled engineers, and a complete ecosystem of suppliers. Stage 3. Cell manufacturing. Gigafactories produce cells at massive scale. Large plants reduce cost through learning curves, automation, and smoother logistics. Why recycling matters. Recycling turns spent batteries into new raw materials. It shortens supply chains. It reduces price exposure. And it becomes more valuable as millions of EVs age. Why every country wants gigafactories. They bring jobs, suppliers, research centers, and long-term industrial clusters. But they also require huge public spending. If manufacturing yields are low, the economics suffer. If yields rise, the region becomes a long-term power in the industry. 4. Winners-losers, industrial level. Winners. 1. Countries that control refining. They can smooth supply shocks and negotiate from strength. 2. Manufacturers with strong cost curves. LFP leaders win mass markets. Sodium-ion players win in cheap storage. Companies that improve yield quarter by quarter dominate volume. 3. Automakers that secure battery supply. Vertical integration, cells, packs, software, cuts cost and protects margins. 4. Recycling firms. They become new suppliers of nickel, lithium, and cobalt without relying on mines. Losers. 1. Companies stuck with expensive chemistries. If a pack costs more without offering more value, the market squeezes them. 2. Countries fully dependent on imports. They face higher prices, longer waits, and vulnerability during shortages. 3. Automakers without supply security. Production slows, margins shrink. Customers switch brands. 4. Startups with great science but weak scaling. Batteries are a manufacturing sport. Lab success does not equal factory success. 5. What it means for consumers. Electric vehicles. LFP lowers cost. Small and mid-size EVs get cheaper. Battery warranties improve. Used EV markets grow as diagnostics get better. Charging networks expand. Fast charging becomes more common where grid power allows it. Homes and neighborhoods. Home batteries become like Wi-Fi routers, common household devices. They store cheap electricity at night or from rooftop solar. They keep essentials running during outages. Community batteries stabilize neighborhoods and reduce peak loads. Grid and industry. Storage flattens power prices. It stores cheap midday solar and releases it at high demand hours. It reduces blackout risk and supports more electrified appliances, heat pumps, induction stoves, electric trucks, factories. Everyday habits change. People learn to plan charging. They watch electricity rates. Energy becomes something to manage, not fear. These shifts feel small day to day, but they transform the entire energy economy. 6. Climate, risk, and the long view. Climate pressure reshapes the map of where batteries matter most. Heat and drought stress electricity grids. Extreme weather increases outages. Renewable energy grows faster than transmission lines. Storage absorbs volatility. It acts as insurance for grids, cities, and homes. For manufacturers, climate change also affects where battery materials can be mined, processed, and shipped. Supply chains must adapt, often at high cost. For consumers, this means more price swings, faster innovation cycles, wide variety of EV choices, batteries in more devices and homes. Storage, in short, becomes infrastructure. It becomes something every country must get right. The battery century is not just about cars or phones. It is about power, economic, industrial, and political. The countries that refine materials, build cells, integrate software, and recycle efficiently will write the rules of the next energy system. The firms that master cost and scale will shape mobility, devices, and the grid. And households will feel the change every time they plug in a car, run appliances, or ride out a storm. Storage is the control knob of electrification. Turn it, and everything else aligns. Where will your country, and your life, fit in that map? Stay curious, stay sharp.